Welcome back, everyone. Here we are with another episode of the Midnight Sessions. Let's get started. Perfect. So now I wanted to share a post that I did some days ago related to why I consider that building in Midnight right now is the best time, right? I list here some considerations, right? So let's see them. First, Midnight is the first Cardano partner chain. So we have all this security, decentralization embedded within Midnight because of partner chains. We have the best-in-class DevRel support, right? I have experienced that myself. So everybody joining Midnight, they're gonna have this DevRel support. This is led by Lauren, the coding. Midnight, it's a blockchain that it's focused for enterprises. We care about privacy, identity, zero knowledge. Then we have Midnight Sessions that it's led by Edda Labs and Mesh SDK. And these sessions are these ones that we are doing right now, where we talk everything about the ecosystem and we learn how to code, how to write applications, and we answer some questions and also do some collaborations on these community boards. Hackathons, non-stop. So anytime a developer wants to start building on Midnight, you have documentation, you have support, and now you have hackathons. So you have collaboration between developers, and then you have incentives. It could be a financial incentive, but also recognition, right? You're gonna get in touch with many developers and business building on Midnight that's they might need your help. Community, the best around. You're gonna see that on Discord. I mean, the people, every time somebody posts a problem, the community wants to help each other. So Discord is really active. We have a string collaboration platforms. This is something that new. We are starting to use this collaboration community board that people can post issues and then requesting, for example, for new examples, dApps, improvements, and then if chosen, they're gonna be executed by members of the Midnight team themselves or also by the community, right? The tooling in Midnight, it's built for developer experience, considering that zero knowledge it's something really hard to do, right? And it was really limited to specific developers that knew how to use that technology. But now with Compact and the tooling within Midnight, this amazing technology, it's open and available to a broader community and domain of developers. And on top of that, something that was just announced is that we're gonna have a decentralized funding powered by Catalyst. So this is huge news. So let's see the post here by Lauren. So before that, I wanted to congratulate Midnight Foundation. They're doing a fantastic job. So let's see the post here of Lauren. So you can see here, it's Lauren and Chris. Lauren is the head of the DevRel team within Midnight, and Chris is from Catalyst. So Lauren says, an exclusive announcement dropped tonight at the Input Output Hong Kong Dev community event in Vietnam. So they are in Vietnam. Chris shared that season 15 of Catalyst will have a Midnight Network category. Amazing. Right now we are in Fund 14. So in the next fund, we're going to have a category exclusively for Midnight. We have this amount for fundings. So I welcome all the developers. There is no better time right now to jump into Midnight and start hacking. Okay, perfect. So now let's talk about this recent blog just launched by the Midnight team called State of the Network, September 2025. The author is Ian McRae, right? So every month they publish these kind of summaries of what's going on within the Midnight ecosystem, right? So the author here included a lot of details about different stuff, right? So what I've done here is I made a summary so I can share you with you guys. So here we have the summary here in English, right? So let's take a look at this together. So we have a open source progress, right? So we've been discussing along these sessions that the Midnight team is releasing and it's open sourcing different repos, right? So now they have listed one of the core repos that they were just open source. So we have the Midnight Ledger, Midnight CK, midnight.js, and Midnight Docs. So what are these repos about? The Midnight Ledger, it's the actual implementation of the ledger of the blockchain. So now it's open source. The Midnight CK, it's all the backend of how the circuits are being implemented, and all the cryptography, how all this magic works under the hood. The midnight.js repos, it's the client SDK. It's how applications actually build transactions, create them, and talk with the node. And Midnight Docs is the repo that concentrates all the documentation about Midnight. So perfect job. Now it's all open source. Everybody can take a look, can collaborate, can change it. They can do whatever they want with these open source repos. Okay, what else? We have some information regarding the Glacier drop process. So they mentioned that over 2.5 billion NIGHT tokens were claimed. Awesome news. That represents pretty much a little bit more than 10% of the total number of tokens that is going to exist in the Meta blockchain. And there's ongoing technical upgrades to the claim portal, right? So where you can find all this information, we have seen that on previous sessions as well. But if you go to this link, midnight.meshjs.dev, you're gonna find different blogs regarding these regarding this drop, right? For example, here you can see that they have added 16 days, right, for the claiming process. So nice. They want everybody to have a chance to actually claim those tokens. They're improving the processes and the ways to actually claim those tokens as time goes by. So if you haven't claimed your tokens yet, you can go ahead for sure. You're not gonna have any issues. But in case you do, I recommend going in this blog called Glacier Drop Wallets and Address Type Compatibility. The Midnight team, it keeps working on adding new features and new ways to actually claim the tokens, and they're publishing all these details in this blog. Okay, perfect. What else? They talk about some research and vision, right? So they say that they just did a report with the blog regarding interoperability, selective disclosure, privacy as foundation for Web3. They mentioned something really interesting. They relate this information with the early days of the internet. So back in the days, like way before 2000, the way the internet was kind of being created, we had silos, right? The way blockchain kind of is working right now. But after the creation of some protocols like TCP/IP, all these silos actually get connected, right? And that's the way we have the internet right now, right? Internet connects different networks. And then different other protocols were born as well that added privacy. For example, the TLS protocol. So in this case, Midnight relates a lot to this process where we are looking for interoperability and privacy. So they say Midnight position as a privacy layer across blockchains. And regarding the interoperability process, we have partner chains. Okay, what else? We have some network growth values, statistics. Let's take a look. More block producers, increase in smart contract deployments and user activity. They shared this graph with some nice values. Let's take a look at that together. They say smart contracts deployed, 3,993, almost 4,000 smart contracts that were deployed on the system. And number of smart contract calls, 5,470 calls. So these calls means one are the contracts on the blockchain, and the calls are the interactions of different users actually calling to that contract that was deployed. Faucets request, how many users are requesting funds from the faucet? In this case, it's dust tokens, 964. Growth in active wallets, almost 800 wallets. That's a lot. And number of block producers, 104. Considering that every block producer in Midnight, they have to be an SPO in Cardano. Okay, what else we have here? Hackathons. So we discuss all the time about hackathons that I really recommend you guys that are entering into the Midnight ecosystem to join those hackathons. You're going to have a lot of benefits and networking that you can do during that process. So they list here some facts about the latest hackathons that took place and are taking place right now. So the mini dApp hackathon was the last hackathon that we had, and they are listing here the winners. We have Edda Labs, and he worked on a project related to private stablecoin protocol. We have Midnight Bank team. They work on a project related to confidential banking app. And we have CK Batch. They were working on private verifiable credentials. And then we had a hackathon in Buenos Aires, which was one of the biggest Midnight hackathons ever. And the winners were projects related to privacy preserving KYC by the team BlockFi, asset tokenization by the team Esteban, and some projects related to sealed bid auctions by Raccoons. So congratulations to all the winner teams. And then we have an upcoming hackathon, which by the time of the blog was upcoming. Right now it's actually taking place right now, right? So it's a hackathon that you can join right now. It's the Dega AI hackathon. So the Dega team, it's doing a nice job putting together a hackathon that integrates AI and blockchain. They have launched and they have published as well some YouTube workshops where they showcase how this integration works, right? For example, a user can, using Discord, interact with the Midnight blockchain, right? They write something on Discord. The Discord bot talks with an agent. The agent using an MCP integrations. They have a tool regarding how to that allows the agent to talk with the Midnight blockchain, right? So this tooling during the workshops, they use some wallets and some smart contracts. And the hackathon, it's actually regarding using this framework and adding some treasury management. So really nice hackathon. If you can participate, I'd really recommend it. And then they announced this Midnight Summit Hackathon, which is going to be the first summit that we're going to have in Midnight. It's going to take place in November 17th to 19th, and it's going to be in London. So a lot of developers interested to go, they submitted their applications. I'm not sure if registration is over, but I've seen that a lot of developers, they have been accepted already in the process. They have sent me some emails, messages saying that they are going. So congratulations to all these selected developers. And for sure, I want to meet you all in London. So don't stop writing me a message so we can meet in London. And this is a link where you can find all this information, right? If you're new coming to Midnight or you're already developing Midnight, if you go to this link, we have the Midnight Awesome Dapps. So the Midnight team is doing a fantastic job putting all this information together so you can have a kind of nice way to find all that info, right? There's a lot of people now, and in the future, there's going to be even more people developing in Midnight. So let's see how this is structured. We have the getting started section. So we have the example counter, example bulletin board, proof share. So this is all contracts being developed by the Midnight team. We have some smart contract primitives. This is being developed by OpenZeppelin. More primitives are going to be coming in the future. So what is nice here, the OpenZeppelin team, they have built a lot of EVM contracts. So now they are simulating those contracts using the Midnight features. So they have Midnight contracts that simulates ERC20 implementations, NFT implementations, ERC 1155 implementations. We have some starter templates. We have the Mesh.js Midnight starter template, the one that we keep working on these Midnight sessions. We have this symbol here, which means that Mesh.js is one of the official partners of Midnight. We have some developer tools, projects related to finance and DeFi. We have projects with relates to identity and privacy, gaming, governance. Then we have some learning resources. We have documentation, getting started, and tutorials. One of the tutorials that we see here is the Edda Labs YouTube series, which is the Midnight sessions that you're watching right now. And we have the Mesh Midnight, which is the official documentation of all the tools that we have in Mesh, right? If you go here, you can see that we have these docs regarding to Mesh Midnight. Okay, so, and then we have some community, right? Midnight, they have some Discord, forums, YouTubes. So all this information we keep looking at during these sessions. Okay, what else we have? Regarding community, Midnight team, they keep hosting weekly fireside hangs that takes place on Wednesday. And regarding partnerships, they announced this partner with Webisoft, and I'm taking advantage of mentioning about as well the partner Edda Labs and what we are building. So regarding Webisoft, they're gonna build a institutional dark pool DEX. So this is a really nice project, and the way they're gonna do this is that besides the product that Webisoft is gonna build, this is gonna include some open source modular components. So different developers can actually take advantage of what it's been developed by the team of Webisoft and use that modular implementations in their own projects. So the Midnight team shared here another post going into much detail about this partnership. So let's take a look here, right? They're mentioning here about the team, what they are doing, but the details that I wanted to share with you guys now, it's the following. We have the project is going to be divided in these 5 milestones. One regarding to system architecture and privacy specifications. The other one regarding to confidential asset and order management. We have private matching engine. So there's going to be an engine matching all these private intentions of the users. And it's going to come with an MPC, right? Because we want to maintain the privacy feature when it's been done off-chain. We have atomic settlement layer, which is the C-swap in Midnight, and some validation and security reports. So really nice project. And then we have the Edda Labs. So Edda Labs is building the structure. It's kind of the partnership of Webisoft, but the products and the details differs, right? So Edda Labs, we're building privacy-enabled products. We are focusing right now into main products, which is renewable energy and waste management. And we're gonna need some modules to build this product, which is identity, tokenization, and DeFi. And those modules are gonna be stored and gonna be open source under the Mesh repositories. So we have this link where we have Mesh.js Midnight contracts. And in here, we're gonna put all the contracts that are gonna be used on those Edda Lab products that involve the contract part, the CLI part, and the React integration part. Okay, amazing. So this is all about the state of the network of Midnight of September. Every month, Midnight publishes a new state. Okay, perfect. Let's continue with part 2, where we left in the last session. So anybody that haven't seen the last session, please go ahead and watch that first, since this one is the second part. Okay, let's continue. We analyze everything about the counter contract, right? So now we're gonna go deeper into the scripts and the functions how to declare the class framework for testing. So let's open here the package.json, and we saw the last time that we have these 4 scripts, right? We have compact, compact fast, compact format, and test. So let's run them and see in practice what they do, right? So we have this counter, which is our contract, and just to make sure that you're aware what's going to be created, right? In this package.json, we're going to create something under source managed. And if we see here under source managed, under source, there is no folder name managed. So nothing has been created yet. So after running this first command, compact, there is a file that will be created with the name managed. Okay, let's take a look. So let's run first this first command, npm run compact, right? So after running this, you're gonna see that the compiler is gonna be working, and it's gonna be it's gonna start creating the output of the circuit, which are the keys, right, of the cryptographic material, the zero knowledge material. Let's take a look. I'm gonna press enter, and you see that it's working. It was really fast because the contract is small, but still you saw that something was being created. And you can see here that the output is this one circuit under the name increment, which is the name of our circuit. And it's here it's the size of the circuit, which is K10, which is 2 elevated to the 10 number of gates, right, of that circuit. The bigger this number, the bigger is the circuit. Perfect. So now let's find this output, which is source managed counter. See, we can see here that this folder was created. So if we open that, we can see that we have the output of the compiler. We have a folder named compiler where we have the JSON of our contract and the specification. We have the output, JavaScript output. Then we have the keys. This is the CK material of our contract. And then we have the CK intermediate representation of our contract. Perfect. Let's see what happens if instead of creating or running npm run compact, this time I run npm compact fast. Just take a look here at the package.json. The difference between compact and compact fast is that in the second case, we are using this flag skip ck, which means that I don't want the ck material to be created. So we can assume that in this second case, the compilation is going to be much faster because we don't have to create any cryptographic material. Let's take a look. Before running that, let me erase this folder managed that we have these folders, compiler, contract, keys, and CKIRs. I'm just gonna erase this. And now I'm gonna run npm run compact fast. See, it was really fast. I mean, that you don't get to see the size of the circuit because there's no material, CK material created for the circuit. And if we see the output in managed, we can see that we just have the compiler JSON, we have the JSON, the JavaScript output for our contract, and we have just the CKIRs, but we don't have the keys. So those keys were not created. That's why it was much faster. Why would we use one and not the other? We're gonna understand that in a minute. Okay, what is another script that we have? We have compact format. So let's see what this format actually does. So we're gonna enter this our contract with the extension .compact. And for example, here in the type counter, I'm just gonna give some spaces here. So you see, it's not in a good format anymore. If I run this command, npm run compact format, let's see what happens here, right? You can see here that the type counter, it's it's away by some spaces. So if I click enter, see, this was corrected. Now everything is well formatted, right? This command actually does other things, but the way we're gonna use it for the time being, it's just by making our code nice, right? We're gonna format it with that command. Perfect. What else? We have this other command test, which actually runs the test that we have included under this folder name test and see if everything passes. And the output of that test is gonna be log under this file, logs logic testing. So let's see. Let's run npm run test. And we can see that all tests have passed. And now we have this file under logic testing with all the tests, with all the logs. We're going to understand what these logs means and how they are created. But for now, it's just for showcasing that after running tests, we can have some logs. Awesome. So now we are ready to actually start understanding what's inside this folder test. So if we enter this first file, it's where we actually create our simulator. So we have this framework for actually creating the simulator. It looks complex, but it's really easy. I'm going to explain you all the details so you can, in other contracts by yourself or with me that we're going to do in the next episodes, we're going to start analyzing different contracts and building different contracts and testing them using this framework. Okay, excellent. Before digging into this framework, I wanted to show you one thing so you can better understand what we are actually testing right now. So for that, I have this diagram that it was shared by the Midnight team in one of the workshops that it was performed, where they show how different parts of the system actually gets connected. I found this diagram really nice actually. So I'm going to explain to you in a really fast way and easy way. So you have the compact program here, right? After compilation, you actually create your intermediate representations and your JavaScript contract.js. Perfect. So you have these two files, and then you actually have your witness, your logic of your DApp, and the runtime. You run your contract.js with your witness using this runtime, and what you have as an output are transcripts. So now with transcripts and the CKIRs, you can actually create your keys to tell the node, okay, I know this secret, and if that proof passes that verification, then this code that was run here, it executes here again. So whatever you run here is gonna be run here using the same virtual machine. So this is really powerful because you know that your logic here, it's gonna, if it passes here, it's gonna pass here. And the semantics are gonna be the same because you are using the same virtual machine. So you can see here that this is an end-to-end kind of application. In our case now, we are only interested in the logic part. So what happens here? This creation of the zero knowledge and the prover keys and the proof, we are not interested because we don't want to talk with the node. We just want to test the logic part of our contract. So what we're gonna do now is create a framework and a class for testing this logic part. Only this part, right? Perfect. That's why we don't need providers. We don't need to talk with Node. We don't need to talk with other indexers. We just need this part. Perfect. Okay, so we're gonna use this logger, which is an instance of these of the class logger. We use this function create logger. We learned that from previous sessions. So it's just for logging, right? And we are gonna create that under this folder logic testing. Okay, first thing, we're gonna create a class named counter simulator, and we have to define in here one instance of the contract and a circuit context. As instance of a contract, we know how to declare that already. If it's of type contract, that it's coming from the output of the compiler, with counter private state. And the circuit context, this is something new, right? That we're gonna learn. Every time that you run something on Midnight, you execute a program in a context, and then you have some output, some effects. So this circuit context is that context that we need to declare to actually execute our circuits. When we learned before the midnight.js SDK, we didn't need to declare this context because the framework was declaring that context and constructing that context for us. In this case now, we have to do it ourselves. It's not complicated, I'm gonna show you how. But we have to declare that we will need this circuit context. And this constructor of the type circuit context, it's coming from the library compact runtime. Excellent. So now we create a constructor of this class. First, we declare an instance of a contract. That's easy. We have already done that. We just create an instance, new contract, and then we pass the witnesses, which is an empty object. And now we are gonna run the method initial state of that instance of the contract. How do I know that I have this initial state? So in this case, what we're gonna need from the outputs of the compiler is that you see here, you have a contract where you have the JavaScript output and you have the types. These types are actually really helpful because it's gonna tell us what we have available from the output of the compiler under the class the contract class. So we have a type of witness, a type of impure circuits, we have pure circuits, we have our circuits, the total, we have an output of type ledger, which is actually the ledger variables we declare under the contract, and then we have our class of the contract that we are creating the instances from. And what we have inside this class, it's a witness, we have a circuits, impure circuits, we have the constructor, right, where we pass the witness, and then we have this other function method, which is called initial state, where we have to pass this constructor context. Perfect. So we now have that we have this method initial state to get a constructor result. Let's go back to our simulator. So we know that to initialize this, we need to pass a private state and a coin public key, right? So this initial state, to create that parameters that we need to pass here, we're gonna use this function that it's coming from the library as well, constructor context, coming from compact runtime, and we're gonna pass here the private state and the coin public key. The private state, it's this one that we declared before. We are not using any private state and witness. The empty witness is an empty object, and for the private state, we're just using a object of private counter of type number. So in this case, we're just declaring private counter, and the number is gonna be 0. And for the coin public key, you are just passing a 64 zeros, which represents 32 bytes of type 0. Excellent. So with this initial state, the output that we actually get is these 3 variables that represents the private state, the contract state, and the cswap local state. What are those? So we have already studied that on previous sessions, but let's do a recap. With these diagrams, I'm gonna share you another one that we already saw before, which is this one. So you can see here that this is all the states that we are taking consideration when doing transactions in Midnight. So you see here that you have your private state, you have your cswap state, and you have Kashina state. So this is the 3 states that we just got from running the function initial state. So you have the private state, you have the contract state, which represents under the protocol Kashina, and the cswap local state. Perfect. With these three variables, now we can start declaring this circuit context. So for the circuit context, this is constructed by using these states, the private, the cswap, and the original state, which is the current contract state, but we also need the transaction context. So how we build this transaction context? Again, we're going to use some constructors, which is coming from the library construct runtime. So we initialize this query context, and we're going to pass a data from the current contract state, and then an address of a smart contract. Since we are just testing the logic part, we haven't deployed any contract. So in this case, we're using this function, sample contract address, coming from compact runtime, for the system to create a dummy contract address for us, right? So perfect. With that, we have created our circuit context. So we have the contract instance and we have our circuit context. Now we are ready to actually implement the functions that we really want to run. In this case, it's get ledger, where we're gonna get the type ledger. And how we get that? We're gonna use this function called ledger. Where is this function ledger coming from? So you see, it's coming from the output of compiler. If we remember from the types, we have also this function ledger that gets the state, the serialized state from the blockchain, and transform that in the type of ledger, which I'm gonna get this round of type begin, which is the type of our ledger, right? This round, and in JavaScript, TypeScript, this counter is of type begin. Perfect. So we have this get ledger. Then we're gonna define this function get private state of output counter private state. And this is simple. We're just gonna grab the circuit context and we're gonna grab the private state. How do I implement the execution of a circuit? Increment. So we're gonna call our contract and we have impure circuits. And these impure circuits are gonna have the method increment. So in this case, increment, we don't have any arguments. If we remember, increment here, we don't have arguments. But why we're passing this circuit context that we defined when we created our class? Well, we didn't pass any arguments before because when we were using midnight.js, what happened is that the SDK itself actually created this context for us. We didn't need to pass the context. And since we didn't have any arguments to declare on the contract, we didn't pass anything. But now, in this case, this circuit context, it's been created by us, so we have to pass it. But since we already have it, that's okay. We know how to do that. Okay, and the result of this circuit, we get the circuit results. And these circuit results, what we are doing here, we're logging the results out. And the circuit results, it's pretty much divided in three parts. One, it's the context. The other part is the proof data, and then the results. So the context, what we get, it's pretty much the states, private state, cswap local state, and the original state. And we also get some address, some blocks, communication indices, and effects, and the new state. So what is these effects? We're gonna take a look in a bit. What are these effects? But what happens in Midnight is that whenever we run a transaction, we, after proving that, after sending the proof to the node and it gets verified, we actually execute a program. And that program does some effects in the ledger, right? We're gonna see in a bit what are these effects. And then we have some proof data. We have inputs, outputs, and we have private and public transcripts. So what are these transcripts? We already saw that, but let's take a look here before. Maybe you didn't notice. So in this diagram, remember that we mentioned, right? After compiling our contract, we have the contract.js and the CKIRs, right? But how do we actually get our prover and we verifier key? This prover key and verifier key are necessary after running this algorithm, right? But in addition with the transcript and put everything in the proving system, it's how we actually gonna create this proof. So the proof is created using our prover key plus the transcript. So this transcript, we get it after running our contract and getting the results of the circuit. So we go back, we get the transcript, we have the output of the compiler. In this case, we don't have the keys, right? So let's see, because we run it with fast. But if we want the keys, we actually need to run the compat command. If we run the compat command, now we have the keys. So the keys plus the transcripts in the proving system, we're going to be able to create the proof. The transcript and the prover key, we create the proof. Excellent. So this is why we need this proof data. So we execute the circuit. In this part, we are actually making sure that all the logic part runs okay, and we get the context as an output, we get the proof data as an output, and then we get the result as an output. What is this result? This result is nothing more than this output of the circuit, right? So you can display it on the client. Excellent. So going back here to the class, and then we just run the function ledger that it's actually gonna deserialize the state so we can see it in a better format. Excellent. So now we have declared our contour simulator with all the methods. What we have to do now, it's actually declare the test that we want to run. So in this case, we're gonna use vit test, right? So we have to declare a file with this extension, .test.pointts, and after running the npm run test, what actually gonna run is this file, and the results I'm gonna log under this logic testing. So what I'm doing here, well, we are just describing this contour smart contract, and we are running here some test. In this first test, what are we doing? We are initializing our contour simulator that we are importing from this other file, and I'm running the method getLedger, and now I'm just comparing that these two states are the same. Obviously, it's gonna be the same because I'm comparing the same variable, but just it's for proving that the framework is working okay. And now I'm just gonna log some state. In the other test, what I'm actually gonna do is I'm gonna initialize the class, I'm gonna get the ledger variables, and I'm gonna compare that the variable round it's equal to 0. And why is that? You remember that in the previous session, I mentioned that the ledger variables, and actually every variable, it's initialized by a default value if you haven't declared anything under the constructor. For counter, the default value is 0, right? So since it's type begin, when we initialize the contract, this value round should be 0n. So this round is this one here, right? Let's see. We have the ledger round of type counter. If we go to the types, let's go to the types. Here we can see that this round in JavaScript, TypeScript, it's of type begin, and the default value is 0. That's why we are saying that the value of round is gonna be 0n. And then we are just getting the private state, and the value of the private state, it should be private counter 0, because that's the type and that's the value we declare when we initialize our simulator. We can see here that's the type that we initialize the counter simulator. So since we are not altering the private information, that value should be the same. So we are comparing that value hasn't been altered. Excellent. And for the other test, what I'm gonna do is the following. I'm gonna initialize the simulator again, I'm gonna now run a circuit, which is increment. And what's gonna happen? Now it's not 0 anymore because I have already increment the value of the counter by 1. So now the value of round should be 1n. And I'm gonna get the private information, and the value of the private information even running this circuit should be the same because we are not changing the private information. So it should be private counter 0, the same as before running the circuit. So I'm testing here all the logic. So to actually test it, what I have to do is just run npm run test. So after running this command, you see here that I just have the output of a previous test. So if I run a new test, I should have a new logic testing result. So see all the pass, which are 3 passed, which are these 3, 1, 2, 3, right? And the output, it's this one. We had 1 log before, now we have 2. So this is the new log. Let's take a look at the output. So the output, if you remember, we were logging out the results of the context of the circuit proof data and the result. So let's take a look. Regarding the circuit context, we have the private state, which is private counter 0. We have our current cswap local state that it's attached to a coin public key. In this case, you see it's 32 bytes of 0, which is what we initialized the class. You remember here, see, we declare it with 64 times 0, which is 32 bytes. Then we have the current index 0, and we have some inputs and some outputs. So what is these inputs and these outputs, right? If you, again, let's remember some other graphic that I showed you before. Let's see here. So here, the cswap, you can see that it's nothing more than a Merkle tree with a lot of commitments. And these commitments are actually coins. And when you create a transaction, what in cswap, how do you actually perform this action? It's just by creating a set of inputs with a set of outputs and a set of transients. That's the way that we interact with the smart contract, right? But you have inputs and outputs. So in this case, you have inputs and outputs and a current index that it's a place on the Merkle tree. And you have a original state, right? Original state is this variable that it's serialized, and now you know how to deserialize it using that function ledger. We have a address, that's the one created with the sample address function, that it's a mock address. Some block hash, and then you have effects. Remember that we were talking about the effects. So what are the effects that we actually have after running a circuit? We can have claim nullifiers, claim receives, claim spends, claim contract calls. We have mints, and that's all the effects, right? So then we have some state after running the circuit, and as a proof data, we're gonna have the input. We have the private transcript output, the public transcript. This public transcript, what it's actually does, it's running a program. So you see here, this is a program in impact. So when you run a circuit, you actually grab the context that we declare it, and we run the program on it. And then we have some effects. So you have the program, which is the public transcript. You have the context by reading the ledger, and then you have the effects. Perfect. And now regarding the results, we just have an empty object, which is this empty object. Perfect. So we have run the smart contract. We have tested logic. We don't need the proof part. We don't need the providers. We just took care of the logic part. Excellent. So in future contracts, we're going to be doing the same. We're going to be able to compile our contracts. We're going to be able to test the logic part using the same framework. We just have to tweak some things to adjust the syntax and the semantics of the contract, but the structure, it's going to be pretty much the same. Okay, perfect. Now, as a question and answer segment, we're going to discuss this community hub repo, right? That we introduced that on the last session, but now we're going to take a look at the different issues and the process in a more detailed way. So we're under the community hub repo, and we have all these issues that have already been created by the community. So we saw last time that there's a lot of issues. And remember that whenever you create an issue, there is all these fields that appear. You can create a bug report, a content proposal, that proposal, documentation improvement, feature requests and suggestions, a vulnerability, right? So the way we want to follow through all these issues is by looking at the project board, right? Here is just for creating the issues. So let's go to the project, and here we can see all these issues that were created. So we know that we have these no status, need discussion, and rejected sections. How a issue passes from no status to needs discussion status. What I've seen so far, this is being done every Wednesday during the DevRel Fireside Hangs, where members of the Midnight DevRel team analyzes all these issues, and depending on the context, they pass this status to needs discussion, so the community can have a more thorough discussion and voting, or they can be rejected, right? In case somebody has already done that work, or it's not aligned with some parameters. So the way it's gonna work, we're not gonna focus that much on no status issues, since this is gonna be done by the Midnight team on Wednesday. And if we have time later on, we can go through all these issues as well. But we're gonna be focusing on the issues under the need discussion, right? Because we want to collaborate, we want to add discussion on this process and actually vote as well. So let's see how all this works. We're gonna start by this first issue and understand how it was created, what it is about. So we're gonna click on that. Animations on how Midnight works. This was created by Steven. He's a member of the DevRel team. So we can see here that there is some template that needs to be followed. This proposal was created on July 16th, right? So Esteban was the member of the team that created actually this framework for the community board project and repos. And since this was early days, probably he didn't complete all this info. But here they say, okay, what is this about? The type of content. I would love to see a video about how Midnight dApps work in a visual animation that helps me understand the dApp development flow. Yeah, pretty much amazing. I would love to see that as well. Summary idea. What is the core idea? What does this matter? It's an educational asset to help developers understand the mechanics and architecture of Midnight. The target audience, he didn't select here, but it should be for developers, actually for everybody, right? It's kind of an introductory material to actually understand how Midnight works, how everything gets connected. Key takeaways. Understand Midnight architecture, able to convey Midnight core concepts, relevant links, and background. Other ecosystems have this, and we should too, right? He's mentioned, okay, he has seen in other blockchains this kind of documentation being created, so Midnight should have this kind of documentation as well, and I totally agree with that. That's why I included these likes, right? So what is the reason that we have these issues under discussions? So people from the community, remembering that everybody can create an issue and everybody can comment on that issues. So here the community should enter these boards and comment on these issues, right? So people can hear comments and also vote. How vote is gonna work? By giving some reactions, right? If you click here, you have these different reactions, right? And in this case, I really like this proposal, so I included this kind of party emoji and the rocket emoji, since I think this is gonna add a lot of value to the community. Not sure how it's gonna work these kind of negative emojis, if it actually counts as one less point to the actual voting system, or how it's gonna work. But the way I'm gonna be working right now is just by giving some emojis to those projects that I really liked to be and I wanted to be implemented, right? So this is the voting system. This is the assignees who's gonna actually do the job. Right now, all the assignees are members of the DevRel team, but in the future, this is gonna be more decentralized, and actually community members are gonna be able to help collaborate on the implementation of these issues. So perfect. See, if this passes, then it goes under triage and it gets implemented. Okay, let's see another issue. We have the contract deposits and withdrawals transfers with native tokens. So let's take a look. You know, open this. This was created 3 weeks ago by the community member Boshako. The type of content, it's a documentation and tutorial, and we have some labels. Content proposals, it's public. So the summary. What is the core idea? What does this matter? A tutorial or example code up showing how to use the SDK to have a contract to receive transfers in the form of deposits with native tokens, the contract exposing a circuit to withdraw deposited native tokens, a dApp which make use of the wallet SDK to manage transactions and coins for depositing and withdrawing to from the contract. The target audience, developers, Web3 enthusiasts, and newbies. Key takeaways: understand how to properly and securely use the wallet SDK API to send and receive transactions without losing native tokens in the attempt. Learn how the contract also shall deal with its own funds when sending out native tokens from to other colors. So he wants to explain how the contract works with actually native tokens and how you interact with the wallet SDK. So this is the key takeaways. There is no assignees, right, so far. Some relevant links and background, right? Documentation available at this link, which is let's open this link. We are under the docs, official docs of Midnight, and we have this documentation of how the wallet API works. So let's see. This documentation right now here, it's extremely confusing for newbies and developers who don't have experience with Cardano wallet management or other similar technology. It would be valuable to have something which explains in detail how and what should be done with transactions created, when and how they need to be signed, when and how to commit them, as well as any information needs to be sent to the receiver in order to properly have the coins created into their wallets. So they want to explain this process. He considers that the documentation in the way it is right now, it's confusing for newbies or people that are not aware how to use all this or how Midnight works to truly understand how to put these pieces together. So I agree. That's why this other issue from Steven, he was mentioning kind of a graphics to explain how Midnight works. It's actually to solve that as well. This I think has the same goal with something more complex, which is contract creation, wallet connection, and interactions. So for example, just putting some context, a new developer getting into the Midnight ecosystem, they have pretty much two ways to get resources from. One is this Midnight Awesome Dapps, right? That the Midnight DevRel team created. It's an amazing repo, so you can find the best resources available in the ecosystem right now, and it's divided in these segments. But what happens right now is that all these projects, they are not for newbies, right? There are projects that won hackathons, so they are considered to be complex. It's a really nice resource for experienced developers and somebody that want to have some, extra context when developing on Midnight. But for those ones that are coming new, they might want kind of a simple contract. So we have that as well. We have the counter contract, the bulletin board contract, but maybe we could explain better how all this works for newbies. So what I've seen is that the Midnight team as well, it's updating the docs, right? So we have the docs, and here now we have a field of getting started. So this is a way for showcasing how Midnight works, how to get things installed, and how to run a first smart contract in a really simple and fast way. You have installation, and then you have create a Midnight app, a really simple app, how to create everything from zero without needing too much template or stuff like that. You can do it just by following these steps. It's really fast to do. So this could be something that the Midnight team is doing to actually explain how Midnight works and how everything gets connected. Yeah, of course, this contract is much simpler than this one here that the proposer is mentioning, that they want to include native tokens and mint tokens. So I actually like the proposals because I would like to have something included in the docs that explain complex concepts in a really fast way. So maybe this could be included in the docs under this getting started create Midnight app. Not sure if it goes beyond what it's intended in here, but it could be a start, right? Well, at the end, this proposal needs more discussions, right? Here, the proposer for sure should have to join all the DevRel hangs on Wednesday, where the actual discussions take place in real time. So they need to push for discussions. They need votes, right, for actually these proposals to pass. And once that happens, then it can go through the triage, right, and get implemented. So perfect. This is for this session. The idea for the following session is to keep on going on these different issues and give some context and comments regarding those. Thanks everyone for joining another Midnight session. It was great learning together. See you in the next episode. Bye bye.